Hello everyone, my name is Mr. Mo Godwin, and today we're going to learn a very interesting topic titled Quantitative Reasoning and Logic. Yep, Quantitative Reasoning and Logic. I want you to come out today, come out with your writing materials, come out with your book, and most especially you're going to come out with your what? Your thinking cap. Yes, you're going to be your thinking cap because today promises to be interesting and fun all the way. In quantitative reasoning as a subject, we'll be learning the topic quantitative reasoning and logic. So if you're ready, I am ready. Should we get right into it, people? Let's get to it, boys. Let's get it, guys. Now, at the end of the day, I'll expect for you to be able to tell me what quantitative reasoning is. Now, you should also be able to give me what logic in maths, what it means, what logic means in maths, and you should be able to interpret the use of symbols in quantitative reasoning. Yes, you should be able to interpret the use of symbol in quantitative reasoning. So let's get to it, boys and girls. Should we? Yeah, we should. Now, what's the meaning and the learning of quantitative reasoning? What do we mean? Yeah, we have it as subject quantitative reasoning, but sometimes we don't really know what it means. So quantitative reasoning refers to attributes of mathematical application and the reason behind the attributes. So we are trying to apply maths, yep, mathematical application, and the reason why we are doing it. You try to explain why you are doing what you've done, why certain answer comes out this way, why you did it, and the reason behind it. So that is all there is to quantitative reasoning, using mathematical approach to solve certain problems. Now, what is logic? Because we talked about quantitative reasoning, we also have to reason logic. Someone is already thinking here. Yep. Logic in maths. Logic is a way of thinking or explaining something, whether right or wrong. So logic refers to a pattern, a method, a way of thinking. Or you're trying to explain something, whether they are right or whether they are wrong. So that is what logic means in maths. In maths, logic means when you try to reason things, if they are right or they are wrong. It's also important for us to know that the shapes or the bar, they don't have definite meaning, because in quantitative reasoning you may be saying shapes, you may be saying all those stuffs. These things literally they don't have meaning on their own. Yeah, that's what we are trying to explain here. But they can direct us to what they really represent. So if you apply your logical reasoning and the use of quantitative reasoning that we've defined earlier, if you can put that together, you'll be able to say, oh, this shape represents what? For example, we say this and that, and someone gives you an equal to 7. You should know that this shape here represents a plus. So the shape themselves, they don't have a definite meaning. Definite meaning means they don't carry the meaning on their own. It is not constant. It depends on usage. Boys, girls, it depends on how the shapes are used. Yeah. So when we're trying to see shapes and try to explain what they are, it's because of what we have seen and how we can interpret the shape. So we are expected to think fast. I know that because I always tell you guys to come up with your thinking cap. We're expected to think fast. And it has to be a arithmetic line of thinking, and we're expected to see things, relationship between figures and the shapes that are connecting the figures, what they mean, what they represent. We are trying to think very, very fast, and with that in our mind, what we are doing then, it is what? Quantitative reasoning. It is then the application of maths, application of what we have talked about so far. So that is what we have in our quantitative reasoning. So how do we use symbols? Yeah, any type of symbol, including signs and letter, can be used to mean anything, like the one I showed you earlier. Symbol can represent anything. It depends on you, the boy or the girl, the student, at this case refer. You're the one that's going to say, oh, I think this symbol, what it represents is a plus. Sometimes this symbol represents a minus, okay? And that's because you've been able to bring it out from your mind. You'll be able to look at the figures and the shapes, and you can relate it with the answer and it corresponds. So you think and reason quickly and understand what the symbol represents. For example, say we have 7 and nobody has seen the symbol before. You don't even know what it means. And I give you something like this, and I put a 4 here and I put another 5. All right. We have that. Let's say we have 2 and that 3. Now, reasoning things out, Someone will think, what does this symbol represent? What does this guy here represent? Mr. Moore, I don't know, but you have to reason out. That's quantitative reasoning. If I have this 7 and this symbol 3 and it gives me 4, and I'm having 5, this symbol and 2 and it gives me 3, it then means the symbols represent what? Can I hear the smartest boy here of the girl? Can you give it to me? Beautiful. It represents a minus. Yeah. So we use symbol to represent different things, and that's what we are doing here in quantitative reasoning. Now let's see. A symbol and number working together to find the unknown. Now, what line of thought do you have to reason? We have 4. Can you tell me 4? Yep, we have basically 4 lines here we have to reason things out. Number 1, it could be a plus. You either try to reason it in an additional way, or you try to say, oh, go around plus. If it didn't work in the plus way, you have to go through the minus. Is that you are doing plus? Is that it's going to be a minus? Probably going to be a times, or best, my best is going to be a division sign. So it's got to be one of these guys. It goes round this guy. Sometimes it could be combination of both. I am telling you, boys, girls, it could be combination of both. And so when the combination of both, you get your answer. We play around these mathematical operators. So we are not going outside. The symbol may mean anything, but mathematically, it must be within the signs. Okay, now let's get to some serious business. Are you ready for this? I am ready. Now we have a sample here to consider. We have 7k. Okay, 7k equals 11. Yep, we have 7k equals 11. So what does that represent? What does k represent? Oh, Mr. Moore, this looks so difficult. Not really, not really. If you look hard, you will see it. Now, 7k. Do you remember open sentence? So they're telling us, what am I doing with 7k that will give me 11? Now, I would like to take through my mathematical operator line quickly, quick one. If I think of times, what number will I times to 7 that will give me 11? No number. So this is not an answer for me. Let's say subtraction. If I think of subtraction, what number can I do? What will I subtract? Nope. How about division? Not really. Then can we look at addition? Okay, Mr. Moore. Oh, okay, I can see a way. That means if I add what? 7 plus 4 is going to give me 11. Wow. That's correct. And another way we can do this, since we have 11 here, we can say 11 minus 7. That gives us 4. Beautiful. Brilliant. Brilliant work. Brilliant job here. So that means what? We have subtracted 11 from this number. And so that means k in this sample, k implies adding 4 or plus 4. Let's see other sample here. It also means what? That k implies 4. Let me remind you, boys and girls, you're going to be given samples in quantitative reasoning. That's what they do to you. You give samples, you'll be given sample, probably 1, 2, 3 samples to check around. Don't stop at 1, okay? When you check sample 1 and you say, hey, I've gotten it. Hey, check it on sample 2, check on sample 3. If it's applied to both 2 and 3, then you are good to go. Like I said in the previous slide, we say k equals 4. Now let's see. 4 plus 12, will that give me 16? Brilliant. It is the same thing here. All right. So can we check for more sample? This is another sample. We have 6v equals 12. What do we do? Use my method. 12. If this is going to come to this side, remember it's going to turn to minus, and my v is going to be alone. All right, let's try this out. V equals now 12 minus 6. V now is what? 6. That means we are adding 6. All right, so 6 plus 6, that gives me 12 here. All right, now 13 plus 6, that should give me 19. Brilliant. Can you see that? It means here, V implies what? 6. Hooray! Hooray! I love this part, man. It means you got the job done. I'm so excited for you already. I'm so happy that we've been able to go through this lesson, having fun, and in real time, we've been able to explain what quantitative reasoning is, what logic is, and the use of symbols. All right, so a quick one before we wrap up for the day. Remember, your follow-up quiz is going to come up in no time. Can you tell us what quantitative reasoning is? Can you tell me? Okay, that's a good one. Who can define unto me what logic reasoning is in maths? All right. Can you explain the use of symbols? How do we use symbols? Does symbol have a constant meaning? Is the meaning static? Are you going to be happy at the end of the day when you see your class work and like, wow, I've done wonderfully well. Thank you so much for listening. My name, remember, Mr. Mo Godwin. And from me to you, I would like to say bye-bye. We'll see another time.